Greetings everyone. This lecture is a continuation of the previous lecture where we were discussing surveys and sampling sizes, and one important consideration in conducting surveys is to determine the size of the sample, and the underlying motivation is to collect survey from a sample large enough so that whenever inferences are drawn based on the sample, they are equally reflective of the population at large. So if you were to focus here on the screen, on the slide here, if the population mean is given by mu and the sample average is x average, our goal is to make sure that the sample average is close enough to the mean and it's therefore representative of the mean of the population, so that when we draw inferences based on sample, it has some meaningful interpretation for the population as well. And the sample sizes therefore rely on two considerations: the acceptable level of error in the estimation of the population mean, and the acceptable level of confidence in the estimate of in the estimated value, which is in most cases mean or the average value. There is a formula for this, and the formula is presented on your screens. Let's look at the definitions. If small n is the sample size, so if n is equal to the sample size, and if we are R represents the margin of error, that is based on our sample estimates, we predefine or preset a margin of error, say a 5% or 10% margin of error, then R would represent that, and then P is the observed value of the proportion of data. So for instance, if I were to take example of transportation, if 20% of the population takes public transit to travel, then P would be 0.2, and that's the proportion of observed value of the proportion of the data. And S is the expected response rate from the survey. Recall from a previous lecture when I showed you the survey execution details from Toronto, you noticed that the survey was mailed to about 100,000 individuals or 100,000 households, but the response rate at the end of the survey was roughly 60 or 60+%. So you have to work with an estimated or expected response rate. If your expected response rate is 100%, then that's well and good, but if it's anything less than 100%, then you have to have this in your estimates, in this expectation of a lower response, a critical input to your sample size calculations. You have to account for the fact that even if you are contacting 100,000 individuals or 1,000 individuals, your response rate would be roughly between 50 to 70%, and therefore you have to draw a larger sample so that you can get the number of people that you really are interested in. And there's another thing called the standard normal statistic, and it's based on it's called the Z statistic, and it's 1 minus alpha by 2, and alpha here is the confidence level. The 1 minus alpha by 2, for example, if you're looking at a 5% confidence, so it would be 0.05, and 1.05 divided by 2 would be 0.025, and then 1 minus 0.025 would be the confidence level. And Z in this case for 95% confidence level is usually 1.96, and you can obtain these values either by using R Commander or Microsoft Excel, or as I mentioned earlier, that these tables are reported in most statistics books. So let's look at the example. Let's say let's assume that 50% of all trips in a city or in an area are made by a particular type of mode. So let's say they are public transit trips, and the transportation planners require an estimate of within plus minus 5%. So the R, or the margin of error, in this case is 0.05, and the margin of error has to be within 95% of the real value of the estimate. So that would be the alpha, which I mentioned earlier, and the Z statistic for 95% confidence level is 1.96. Let's assume that the expected response rate of the mailback survey is 60%. So we plug in these values, that is R is equal to 0.05, Z statistic for 95% confidence level is 1.96. The response rate S is 60%, and the proportion is 0.5. We plug in these numbers in the equation here, and the result is 2,561 households. And I will take you into Excel to illustrate this further. Let's say Z is 1.96 and P is in the earlier example P was 50%. Let's say the proportion of the population with that particular characteristic is 25%, and the margin of error is 5%. We want to be within 3.5% of the true value. And let's say our response rate, because we are doing very extensive marketing and community mobilization, that we believe that our response rate would be not just 60% but 75%. So I just entered this number here, and it gives me the value as 12,544. So roughly I need to collect information from 12,544 individuals or households based on the sampling unit that we have decided earlier. So this is the sample size. It is dependent again on the margin of error, the acceptable margin of error for us, the expected response rate, and also the level of significance in the data. So as mentioned earlier in the earlier example, we said that we require an estimate to be within 5%, plus minus 5% of the real value 95% of the time. So the tail would be 5% divided by 2 on the left and the right end of the distribution. Now you have to adjust this ideal number based on the population size, right? So if capital N is giving us is used to denote population size, the total population, then we have to ensure that when the sample size increases, when the sample size is greater than 10% of the 10%, then we modify the values using another formula, which is given on your screens here. So this is applicable when you realize that the sample is greater than 10% of the population, and the formula is N1 is equal to small n divided by 1 plus small n divided by large n, or in actual terms, the sample size divided by 1 plus sample size divided by total population, to adjust the sample based on the population. Now let's assume from our previous example that the sample size of 2,561 was drawn from a district with a total population of 8,537 households. So if you look at this, that you're drawing a sample of 2,561 households from a district of 8,537 households. So the sample of 2,561 from a population of 8,537 is certainly larger than 10%. So the sample is more than 10% of the population. So therefore we adjust the sample by using the formula that we take the sample size and divide it by 1 plus sample size divided by the population size, and this adjusted sample size is now 1970, and I have illustrated this in Excel here. Let me just put back replace the figures to meet the same as expressed in the PowerPoint slides. The margin of error is 5% and the response rate is 60%, and notice that we get the 2,561 as our response sample size. Now let's say the total population is 8,537. I plug this in, click enter, and I obtain the revised sample size, which is 1970 households. Now comes the question of pre-testing the survey. You have determined the sample size, you've designed an efficient questionnaire, and now it's time to pre-test the survey. So the goal is to pre-test it on a small sample to test the sampling methods and questions. And in practice, this is the single most important step in conducting a survey. Without pre-testing your survey, you are bound to make mistakes because you would not know where your survey instrument falls short of expectations, where it becomes irrelevant, and where it's almost impossible to complete it. So it is far better to make mistakes on a smaller sample than to revise the survey and redo it completely. Now, the question of survey management. For very large surveys, the survey management process is critical, and not only critical for quality control and response rate, but for cost control. And I showed you the example from Toronto that the cost per completed survey was around $26 in 1986, but this survey was repeated every 5 years, and there was a very good management team in place, which was actually placed at the Joint Program in Transportation at the University of Toronto, and they were involved in improving the survey management and execution, and the result was that in 20 years or so the cost per survey went down from $25 cost per completed survey to roughly $15 and change. And this is one example of good cost control, and over time you see the proof for this. The quality control for survey is very important, because while the survey data are collected and is being entered into databases, a dedicated team of quality controllers should be reviewing those tables and newly created databases to ensure that the collected data does make some sense. And the response rate is another example. For instance, there are cases where after the survey where it was realized that a particular segment was never surveyed, while there was every intent to reach out to that segment. For instance, if you are conducting a survey and your sample is drawn from a telephone book, and mostly the published telephone books are contain only landline numbers, and the wireless numbers are not listed in the telephone books. Now that creates a problem. If you're not aware of this limitation and you conduct a survey, you would miss all households that do not have a landline, but they may have a wireless telephone. So response rate and other quality control measures ensure that you would be able to look at these errors while the survey is being tested or executed, and then may take measures to rectify those, rather than completing the survey only to realize it after the fact. So what is entailed in survey management? You have to recruit and train interviewers, and that's a very, very critical element. Your interviewers would be the key factor that would determine the quality of the survey being conducted. If the interviewers are serious and committed, they would make all efforts to ensure that data are properly collected, and the information received from the survey respondents is quickly and efficiently and correctly communicated, and is also archived in the databases. The supervision of survey staff is very critical. Now, it's a common practice that when telephone-based surveys are being conducted, the managers would automatically dial in and listen to the surveys and overhear them as the interviewers are conducting surveys, so that they could see if the interviewers are paying attention. There are many instances where interviewers have gone off the script with the respondent, and that should be checked, and that there should be random checks on the process, so that interviewers know that their supervisors would be listening in to the survey, so that they could stick to the script and be efficient and be honest about it. In the management, those survey managers also have to be concerned about the data capture and cleaning. The data have to be archived, and while the survey is being executed, it has to be coded right away in digital format, and then have to be backed up in real time. And the right way to do it is to have multiple backups in multiple locations, so that in case of failure or theft, one is still left with a valid copy of the data. And then once the data are captured and databases are created, the data cleaning process starts, where you have to identify outliers, and then you have to decide if these outliers were actually outliers as communicated by the respondents, or these outliers are a result of incorrect data entry, or that the interviewer may not have heard the respondent correctly. Finally, once you have done the survey, the purpose of the survey is not to keep it secret. The purpose is to analyze it. The purpose is to find the answers to the questions that you are interested in, and then communicate those results to the public. And in the case of political polls, those survey results are released regularly to the general public, to mass media. There's an interesting Pew Research Center in the United States, and that does a lot of polling around the world on various international issues. And the moment they complete the survey and it goes through all the data capturing and cleaning processes, and once the data are analyzed, the results are communicated globally and they are released to the media, and then newspapers and academics and other stakeholders benefit from those results. So the communication of the results to the public is a very, very critical element. You have to decide in advance, once the survey results are compiled and ready to be released, how would those be shared with the public. Now, within the realm of data management, you have to worry a great deal about data storage and the documentation procedures and whatnot. You have to rely on good, reliable database management systems. Even if your data contain a few hundred observations, or if it contains a few million observations, you have to have a very safe and reliable database management system. And the goal should be to use a platform that is time-tested, proven, and the likelihood of failure or a crash in the database are low, and it's designed in a fashion that once your database is complete, it is able to link to other data sets, because we do not work in isolation. If I am collecting information on travel behavior or consumer behavior in a city, there are other individuals who are collecting information on some other aspects, and so databases should be designed as such that my database could be linked to another database at a later stage, and there has to be those key variables, or those ID variables designed in a fashion that multiple databases could be linked together. And another key thing is to keep the database alive and useful. Sometimes some surveys are run perpetually, and if that's the case, you have to make sure that your database is updated on a regular basis. Now let's look at the questionnaire design, and we'll focus on the very issue of how we design a questionnaire. And virtually all surveys ask some sort of a question, and the goal is to have the survey designed in a fashion that is able to collect the information, and the key thing is to make sure that the quality and nature of the question asked is good, and following considerations should be made. The questionnaire by itself should not be very long. You may have the desire to ask all the relevant, pertinent questions, but make sure that you know that as soon as the survey hits 15 minutes, the chances that the respondent would abandon the survey and leave would increase substantially. If a survey could be completed in 10 minutes, perfect. In 15 minutes, okay. In 20-25 minutes, you're pushing your luck, and 1 hour survey, it's very, very rare that people would be answering your question for a complete hour with full honesty. And often we have learned through our experience that in long surveys, people the respondent becomes a little smart and realize that they now would be engaged for a very long time, and they start answering the questions in a fashion that they think would shorten the length of the survey. Now, I give you an example. For instance, if you're surveying individuals about how many trips they made, and then you're interviewing a member of the household, and now 20 minutes have passed and he or she has just informed you how many trips they made yesterday, or the origin of the trip, the destination of the trip, the purpose of the trip, the routes taken, the modes used, and so on and so forth. And then you ask, okay, thank you very much for this. Now tell us about your brother who lives with you. How many trips did he make? Where did he go from? So the respondent would record the information about the brother, and then you say, okay, so now let's move to your son. And if 30 minutes have passed and you ask this question to the respondent, say, so how many trips did your son make? chances are the respondent would say, well, my son remained at home all day. He didn't go anywhere, even though the son may have made a few trips. But the respondent would be sort of motivated to say, well, he didn't make any trips, because now he knows that if he goes on to recording his son's trips, he will be engaged for another 10 minutes. So you have to be very mindful of these considerations. You have to be careful with the length of the survey. Try to make surveys no longer than 15 minutes, and you'll get good response. The layout should be very clear. If it's a paper-based survey, it should be clean. The flow should be visible. The survey paper and the design, even if it's digital or computer-based, it should be appealing. The instructions should be very clear. If you want the respondent to select all that applies in a question, for example, if the question is, do you like to travel by, and then the options are car, motorbike, public transit, and if you want them to select more than one, if it applies, then you should have that instruction, select more than one if applicable. And so these types of instructions should always be there, and the design of individual questions should be very, very clear, explicit, and you should avoid ambiguity at all costs. Survey questions should be very straightforward and clean. The questions must be understandable. Avoid asking complicated, long-winded questions. The questions should be answerable. Do not ask a question which is not a question. It should not be a comment disguised as a question. There should be a question which is easily answerable. And these should be well motivated, and they should be useful. I mean, the question has to be useful to you as a researcher, so that when the answer is given, you are able to use it in your research at the end. And it should be exhaustive. That is, if you ask a question and give people 4 options, but there was a 5th or 6th option that you did not give, then the response would not be exhaustive. For example, if you ask people, how do you travel to work, and you give them 4 options, public transit, drive, passenger, that is, you're not driving in a car, but you're a passenger in the car, motorbike. So these are the 4 options, but you did not ask people about bikes or pedestrians, and then from this question you come up with an analysis and conclude that 45% of the people travel by mode X. That would be wrong, because you did not ask people questions about the whole the entire possibilities of modes that exist out there. So what should questions must not be? They shouldn't be double-barreled. They shouldn't use double negatives. Avoid technical jargon. If you're asking questions about how you travel, don't ask questions about mode split, which is a jargon. Do not ask questions about willingness to pay. Willingness to pay is jargon. Ask people, would you like to pay, or how much would you like to pay? Long-winded questions, avoid them. Very brief, succinct questions are preferred. Avoid biased questions. Do not say, why do you like this, but have a question in which the respondent should tell you if the respondent likes or dislikes. Avoid redundancies or redundant questions. Avoid self-evident questions, and sometimes people do have these self-evident questions. If somebody told you that they were alive in July 2005, do not ask them if they were alive in June 2005, because that would be. Do not ask overly intrusive questions. If you know, and that you have to know about the culture in which you are surveying. Do not ask people overly intrusive questions. Certain cultures would have some questions as regular and would not be considered intrusive or something that the people would be, the respondent may not be willing to comply. But this comes from your own experience. You would know, based on your experience of the culture, that an intrusive question may make the respondent uncomfortable, and you have to avoid asking that question. Also, I've noticed that in some cultures there is no tradition of answering questions on a scale of 1 to 10, and often in North America and in Europe we ask people on a scale of 1 to 10, 1 being happy, very happy, and 10 being sad, how do you rate yourself? Or on a scale of 1 to 5, 1 being very satisfied and 5 meaning 5 standing for unsatisfied, how do you rank certain experience? And there are certain cultures where these ranking is not common, where the psyche or the people's understanding is not does not appreciate these shades of gray which move from very like to very satisfied to somewhat satisfied to extremely unsatisfied. So make sure that when you are offering these scales and asking the respondents to record their sentiments or responses based on certain scales, that the culture, there's a cultural foundation for such questions. If there's no previous examples or understandings, then avoid such questions. In transportation, to give you an example, there are multiple ways to ask questions. You can have an onboard survey. For example, you can be on a bus and asking questions. You can have a mailback survey or a telephone survey or a home interview survey. In market research, you can have a home interview survey where you can actually select neighborhoods in a city, and after selecting neighborhoods in a city, you can select households from that neighborhood, and then you can knock on the door and do a home interview. I already explained what telephone surveys are. There are certain advantages of the mailback service. They are cheap because once you designed it and once you know the addresses of the respondents, you can just mail them the survey with and of course you would have the proper procedure is that you send a letter in mail in advance informing the household that they will be receiving a letter, a survey from you in a few weeks, and advising them and requesting them to comply. If you can use community leaders or if you can use government officials to build up your bona fides, then you can send a letter from community and also from the government in support of your survey. And then the survey arrives in an envelope, and it also contains the survey questionnaire and a self-addressed stamped envelope where the questionnaire is filled, and the respondent puts the questionnaire back into the envelope, which has your name and address as well as the stamp on it, and then you receive the response back in mail. So this is the cheapest way of conducting surveys. You can ask for extensive information because the respondents could actually complete the survey in not just one sitting. They can take time, fill half of it today and then the rest tomorrow. And the household-based sampling frame, if it's well defined, then this type of survey is very good, and you can use it in a wide variety of applications. The primary disadvantage of mailback survey is low response rate. Because you are sending survey requests by mail, the respondent may or may not respond, and they receive a reminder from you and they toss it off in the garbage, and this happens a lot. So mailback survey often have low response rates, and sometimes they're inefficient and sometimes they're potentially biased. However, about 50 to 70% response rates is a common occurrence in North America if the survey is properly executed. The telephone-based surveys are also very useful. This is telemarketing, but not telemarketing in some terms of selling a product, but soliciting information. It can be an efficient use of the interviewers. You can have good supervisory control because you're listening in, and when the surveys are conducting, the managers are always listening in. There's a good response rate. Sometimes people feel compelled responding to a survey when the interviewer is on the other side of the telephone and at the other end of the line, and you can also get a reasonable amount of information. And the interviewer could be recording the information on paper or could use the computer, and that would be a computer-assisted telephone interviewing. Now, the computer-assisted telephone interviewing has an advantage that in case you ask people, the respondent question, how many kids do you have? And the person says 2. Then, and the survey is about the education quality. So the computer-assisted telephone interview would have a program, a well-designed survey instrument, where it will automatically ask about the first child and the second child. It would not ask about the third child because the program is designed in a way that it builds the remaining, as it collects information from the respondent, it builds the rest of the questionnaire based on what the information has been provided. So the next time around, if the next respondent says that they had 4 kids, the questionnaire would automatically change to 4, and it would solicit information about the first child, the second child, the third child, and the fourth child, and then move to the next question. So the next time around, if the next household has not 2 but 4 children, the program will adjust itself, and instead of stopping at asking questions about the second child, it would then ask questions about the third and the fourth child accordingly. So this is the advantage of using the computer assisted technology, because the survey instrument would adapt itself according to the information provided by the respondent, and therefore it is a preferred way of collecting information. Also, once the information is collected using the computers, it is digitally archived and the database is populated at the back end automatically. The disadvantage of using a telephone survey are that the respondent must have a telephone. You cannot conduct a survey for a household that does not have a telephone. Now, we did some surveying and we realized that in many parts of the world now, including developing countries, increasingly large number of households do not have a landline. And in the absence of having a landline and not having access to telephone numbers, mobile telephone numbers, that is, the survey would have a bias in terms of who is being surveyed and who has been systematically left out of the sample. The call screening is another new technology that is widely used in the developed countries in Europe and North America, where the market researchers are being prevented now by law, and also the households are trying to look at the number and see if they don't recognize the telephone number, they wouldn't pick up the telephone, and therefore you have been screened out, and that is becoming an increasing problem. There is also certain biases in example from North America would be that often during the daytime only the senior citizens who are retired are at home, and if you're conducting a survey during the daytime, the workers are at work, those who work are at their work locations, and you would reach the senior citizens more often than otherwise. And also, if there are frequent travelers, they would be less likely to be caught at home for the survey. And then if you're calling in the evenings, people are less inclined to talk to surveyors because they may be interested more in spending time with the family. You cannot ask very complex questions on telephone, because the mode does not lend itself for complex questioning, and there is respondent bias as well, because people start censoring themselves. There are certain emerging survey methods. There's one being developed at the University of Waterloo by Professor Sean Doherty, and it's called Chase. And what they are trying to do is they are looking at the telephone sets, the wireless telephone sets, and they are building these passive survey questionnaires or instruments into the system, that as individuals go about their daily routines, their cell phones would be recording information about them. Of course, with the complete knowledge of the respondent and with their consent. These types of new passive survey collection instruments are becoming common, and as cell phones become more and more powerful and start and they can be used for multiple purposes, such as the location of an individual could be known with great level of accuracy now within a few hundred meters the location could be determined within a few hundred meters of. So such telephones are becoming more useful for modern day surveying, because passive data collection is preferred, because individual is not sitting down and answering questionnaires, but somehow the cell phone is recording the required information. There are companies that design a lot of these survey instruments, online survey instruments, and of course some services are available for free, for others you have to pay. I have introduced earlier you to Google Docs for word spreads, word processing and spreadsheets. Google Docs also offer you a free questionnaire design alternative. You can design your questionnaire and you can actually print it for a paper-based survey, or you can use Google Docs to design an internet-based survey and execute it, and all the responses would be collected in a spreadsheet. The global positioning systems, the GPS, and also the GPS-enabled cell phones are also becoming very handy these days in determining people's movements, and also where they live and where they shop, and such type of information is becoming readily available to market research. Now, most surveys are cross-sectional surveys. You conduct a survey and you collect information about individuals, and that's a snapshot about that individual as a person or as a household, of their behavior at one point in time. But often we are interested in behavior changes over time, and in that case we design panel surveys where panels are recruited, so an individual household will be recruited, and they will be surveyed over time again and again, so once every year for 10 years, or once every 5 years for 20 years. And there's a whole host of variety of techniques, recruiting techniques, and how government actually recruits individual households to track them over time. Another example would be that universities may want to know how their graduates have performed once they graduated from the university, so they are recruited in a panel, and their career movements are tracked over 20-25 year period. So all this is very interesting to provide a time series information. You can also have retrospective surveys, such as you can ask someone to describe their locations, behaviors over time, and ask information not just about yesterday but over the last 20 years. For instance, you can ask people, if it's a housing survey and you're trying to determine what is the level of housing mobility over time, you can ask an individual about their housing tenure, that is, they owned or rent, and where they lived over the last 20 years, and that would be sort of a time series built into your data set. Now let's talk about the database development. We come to this stage after we have designed a survey, retested it, executed it, collected information, created a database, and now that we are creating a database, what considerations should we have? And you would notice that the topics that I have here require you to be mindful of these concerns as you are designing the questionnaire. The databases are mostly in the following format. Observations are recorded in rows, and the variables are recorded in columns. And the most important thing about a database is the primary ID. The moment you start recording data and creating a database, you must have the first column dedicated for primary ID, and it could be as simple as 1, 2, 3, 4, 5, 6, where each individual respondent is assigned a unique ID. And this is the most critical thing, and this is the most commonly made mistake at the undergraduate level. Even some graduate students make mistakes, and even some professionals make mistakes. So they have a database, but individuals are not assigned a unique ID, and it creates a whole host of problems later as you're trying to merge data sets with other data, but you cannot do so because you do not have a primary ID key. Now there could be more IDs than just a primary ID. For instance, if you are conducting an international survey, then every respondent should have a country ID, so that you know which country they belong to, a province ID, so that you know which province from within the country they belong to, a city ID, because there are more than one cities and provinces, and then afterwards the household ID and the individual's ID. And you can also have some census related IDs, because census have information collected at the metropolitan areas, at the census tracts, and another finer geography where individuals could be assigned to those geographies. So be very careful in the very first instance that your surveys should have IDs and multiple IDs, and they should be designed in a fashion that if there is a need to merge these data sets later, you are able to do so in an efficient manner. Let me now talk about data dictionary. A data dictionary contains the details about your database, and not just the details about the entire database, but details about individual variables, but also details about the individual values within recorded in individual variables. The data dictionary would have detailed variable description. Let's say you have a variable called age, right? Now you may assume that this is straightforward, age is age, but let's say that the age was recorded in not in terms of years, but in terms of categories. Under 25 is one category, between 25 and 45 is another category, and so on and so forth. And under 25 was assigned the value 1, between 25 and 45 the value 2, and between 45 and 65 value 3, and over 65 value 4. So the database has this variable age recorded as 1, 2, 3, and 4, and if you find the mean value for this, you may get an average age of 2.2, right? Whereas the average age in your population would maybe 45 or 50. So if you do not have access to the details about this variable, how this variable was collected, and what these factors represent, 1, 2, 3, or 4, you're likely to make a mistake. You also need to know how the variable was collected. If a survey was conducted in summer and you're trying to determine information, how many jackets or winter coats were sold, you need to know this, that the survey was conducted in summer, and of course the sale of winter jackets and coats in summertime is a little less than one would have in winter time. You also need to know how the data records the variables. For instance, the variable, if it's the name of the country, then the variable would be a string variable because all entries would be characters. It could also collect information as integers when the age of the person is recorded, and it could also have the information as real data sets where age could, such as age, because age could be 45 or 45.2. So you have to be mindful of these concerns, and you have to record this information about your data much in advance, so that once you complete your analysis and you have to revisit this sometimes later, you don't have to rely on your memory, or if your data are used by others, then they can look at the data dictionary and know exactly what each and every variable represents. A common practice, even amongst experienced data analysts, is not to pay much attention about the missing values, and that creates a large headaches for those who would like to be careful about their analysis. And this missing value creates all these problems. And I give you an example. Let's say that a survey is being conducted, and the survey asks individuals information about their demographics, age, gender, whatnot. An age variable is collecting information in terms of years. So how old are you? And the person says 45, 65, 22, and that information is being recorded. However, in instances where the respondent refused to reveal their age, then you have to assign a missing value there. And the missing value could be anything. And let's say by default you use 99 as the missing value. Now that would be a very wrong move. For age, 99 is a valid answer. A survey respondent could be 99 years old. So do not use 99 as the code for missing value. For example, how many kids do you have? The response could be 1, 2, 3, 4, and 5 or more. But for this question, how many children do you have, one can use 99 as a code for missing value, because having 99 kids, it's still not outside of the realm of possibilities, but certainly it's not that common. However, for age, using 99 as a missing value would be extremely wrong, because if you have a lot of missing values in your data set about age and you compute average from that data, that age would be biased because it would be biased upwards. Also, to notice that when you're recording information about categorical variables, for instance, information about gender, and that information is often stored as 0 or 1 or 1 or 2, where the person's gender is recorded as 0 is male and 1 is female, or 1 is male and 2 is female. Then if 1 and 2 are listed there, you would not be able to intuitively know if 1 is referring to male or to female. So you have to come up with value labels so that when you collect this information and the respondent records when you collect the information about the respondent being male or female, the data dictionary should inform us if 1 stands for male or female, and it's in the absence of such an information, it would be impossible later to know this information when you start analyzing, and it would certainly be totally impossible for others to work with your data if they don't know what 1 stands for. Does it stand for male or for female? Now let us look at a data dictionary. This data dictionary comes from Statistics Canada, which is the statistics division of the Government of Canada, and it has the mandate to collect information such as census, and a whole host of other socioeconomic surveys are conducted by Statistics Canada. It's one of the most well-established, most reputed statistics organization in the world. Now, if you were to focus on your screens, you would see that this is a data dictionary, and it's called the public use microdata file. It's a small sample from a very large file which is being made available to academics and other researchers. And if you look at the file, the first thing you would notice here, there's a variable called the case ID. This is that unique identifier, that primary ID field, and you would notice that the field name is case identifier, so that's the long name, but in the database the variable is identified as case ID and the long name is case identifier. And then there's a description of this, a number uniquely identifying each household within a reference year, and then the unit of measure is called code. But see, the three things that are more important here: there's a long name that identifies the variable, because if the variable has an abbreviated name and that abbreviated name may lead to confusion, the long name would then be used to avoid such a confusion. If you look at the second variable, it's called weight, and notice that it's field 2, so it tells you that this is a second variable in your database, and the long name of it is weight at household level. So as I mentioned, that when you do sampling, you collect information from a sample from within the population, and that sample is then assigned a weight. That weight is basically informs us that even though this is one observation, this household it represents maybe 5, 10, 15 or 100 households. So the weight is basically a way to use that one observation and assign a weight so that it reflects the weight it would exert in the population. So a 10% sample would have each observation assigned a weight of 10, and a 5% sample would have each observation assigned a weight of roughly 20, and so on and so forth. And the description of the variable weight is the estimated number of actual households this sample household represents. So now you see the description and you understand completely. So when I received this database, I also received this data dictionary, and therefore it allowed me to actually know what these variables stand for. And I will actually now scroll down a little bit, and I'll show you an example of another very useful technique. Now here, look at the variable called province, and it's province P. It's the fourth variable in the database. The long name is the word province, and it is a code indicating in which province or territory the household resides. Now if you look at the values for the code, the value 10 stands for the province Newfoundland and Labrador, and 11 stands for Prince Edward Island, and so on and so forth. Now these numerical codes are used to denote a specific province, and if you're in the database that you get, if you have a province coded as 11, how would you know what 11 stands for? If the province is coded as 35, how would you know that 35 stands for Ontario? So this data dictionary then provides you with this information, so that you can link the data and the codes back to the intended purpose or the intended name of the province, or whatever the purpose was. Now if you scroll down further, you would notice that there's a field called RUR. It's an urban rural code. So every individual household is assigned this code, and the code is assigned as 1 being urban and 2 being rural. So if a household is urban household, this variable would have 1 in that place. If the household is a rural household, the variable would assign 2. But then these things, urban, rural, has to be known to you as a researcher, that 1 stands for urban and 2 stands for rural, or otherwise you wouldn't be able to ascertain this just by looking at the variable. So let's switch to our Commander and see how we use this information. Now the first thing I would like to see is I would like to tabulate the variable case ID, which is the unique ID that is assigned to every individual. And I have already got this data set open, and I am using the script window. I have this script highlighted already, and I click submit, and notice that the quantiles are give me the real information. The lowest value in the data is 1, and the highest value in the data is 14,154. So it tells me that there are 14,154 individuals in my database, and the case ID is assigned to each individual household. The smallest ID is 1, and the largest ID is 14,154, representing the 14,000 odd households in the dataset. Now, there was a variable called urban size. If you look at it here, it's called urb size p. It stands for urban size, and it's a code indicating the population of the area in which the household resides. It has 4 codes. 0 stands for masked records. There are times when the government thinks that they have to they wouldn't like to release information about certain areas because of the privacy concerns, so those records are masked. But in the sense that their location is masked from us, not the entire information. 1 stands for 100,000 and over. This means that the household belongs to a place where more than 100,000 people reside. 2 stands for areas which have a population of less than 100,000, and 3 stands for rural areas. So I move back to our commander, and I just click on this code here and say run, and here's the information. If you look at it, the database informs me that rural households, 18% of the observations were rural households, 24% of the observations were from areas where the population was less than 100,000, and 57.5% of the observations were from areas with a population of 100,000 and over. And lastly, if you were to look at the numerical summaries, it tells me that, and now I'm looking at the weight variable. Remember, the weight is assigned to each and every household, and I'm trying to figure out if what type of weight values were assigned to households. Do rural households have the same or similar weight as to urban and larger size households or larger size population? And if you look at the 3 categories here, and I'm going to highlight this, notice that the weight assigned to each individual in the urban areas is around 1,081, and these are the individual households residing in neighborhoods or areas with a population of 100,000 and over. The weights assigned to rural household is 564, almost half of what the weight is assigned to those who live in bigger areas. So this tells you that the rural areas households are assigned a lower weight, which is an indication that the surveyors have extensively surveyed those areas. So there are more people surveyed as a percentage of the population in rural areas than the individuals sampled in large urban areas as a function of or as a proportion of the population of large urban areas. And the weights are different, obviously, based on the extent of sampling. So this concludes our second lecture on surveys and sampling. The purpose of these lectures were to introduce you to how the survey questionnaires are designed, what considerations you should have, what type of sampling procedures are taken, and all of these discussions led to the final part where we showed you a very well-designed data dictionary and a very well-designed database, and how those data dictionaries are useful. You must have a data dictionary. Even if you have 2 variables, I would suggest that write those variables down in a Word file, in a text file, so that you know later what they stood for. I hope this is beneficial for you. It will be beneficial for you when you are designing your own surveys and are in the process of collecting information. Thank you, and good luck with your sampling.